Welcome and shalom to all our guests who are here today on Earth Day, and greetings on Earth Day to all our participants. Earth Day is, of course, symbolizes what we all are involved in and the kind of work that we all are doing to conserve water, to save water, to treat water. Today, during our webinar, we have two very important topics, critical topics actually, that are to be discussed. The first is non-revenue water, and the second one is going to be agricultural water, which is 80% of the water consumption. To take on this topic of non-revenue water, we have with us Levy from Israel, who will be taking us through the basics of non-revenue water and the strategies to cure this solution. Just for everyone's information, which people probably know, Mumbai city loses 25% officially of its water that comes into the city. This is a huge burden, financial, environmental, and technological burden on the entire city, and this kind of a problem is faced worldwide. So Levy, it's over to you. Please take us through this fascinating world of non-revenue water. Levy?
Sir,
you have to unmute.
Prompt. Can you please unmute?
That's it. Do you hear me well?
Yes.
Yes, ROMIEL? Okay. So first of all, I have to thank you, ROMIEL, because you said Levy Eshkol. Levy Eshkol was the Prime Minister of Israel before a lot of years. There is no relations or family connections. I am Levy Frenkel. And some words about me. My name, as you read it, Levy Frenkel. I'm a mechanical engineer. I was born in Israel in 1951. I am married plus 4 children. Until 3 years ago, I worked in Mekorot. About Mekorot, you heard a lot, for example, by Mr. Niv Pintov. I worked there as mechanical engineer, dealing on water accessories like valves, check valves, water meter, air release valve, relief valves, etc. It's a very big amount of accessories. Also solving hydraulic problems like water hammer, cavitation, water loss, and also developing some innovations and patents. Some of them also patents that are used in United States. I'm also a member in the Israeli Standard Institute in a lot of committees. And in some committees, I am also the head of the committees. And also I am a member in some international committees. For sure, all the committees are dealing with water supply. After my retire, I work from time to time in some colleges in Israel in subjects that are concerned to water. And unluckily, I haven't been in India up till today. I hope to be there when the COVID-19 will leave the world and it should come back as it was before. Next slide, please. Non-revenue water. Some basic facts that we will see later are facts that the United Nations, I would like to say, United Nations declared in 1992 that 22nd of March should be the day of the water all over the world. And by this declaration, this year, I read what they gave this year about the declaration, and some of the data that they gave this year, we shall see it later in my lecture. Also, let's remember that today, exactly 1 month after this day of 22nd of March, it's the day of the Earth. The United Nations declared that the 22nd of April should be the Earth Day all over the world. Next slide, please. Treatment on water with no income comes in the last year to more professional with a great effort to minimize the water loss. That means it's not only a problem of India or of Israel, it's a problem all over the world, and the effect of the loss, we will see it later in this lecture. Please, the second one. What is NRW, or non-revenue water? Water for which there is no revenue charge. That means water, please, the next slide, it's more, you can see. You see a simple formula. The price of the water that you produce minus the price that you get for the water bill, that gives you the non-revenue water. This is the non-revenue water that you get, and as I say, it is one of the things that is we have to be. In fact, I'll speak about it, and we have to put a lot of effort to minimize the NRW. The second one, please. From the data, as I told you, what was given in 2020, this is a year ago, the data was here. In 2020, they said in this International Committee of Water that 1.2 milliard, I don't know how you say in India, billion or milliard. In Israel, we say milliard. 1.2 billion people in the world don't get regular supply of potable water. But by the data that was published in the New York Times before about 3 weeks, the United Nations declared that this year it comes to nearly 2 billion people in the world that don't get regular supply of potable water. Let's remember that in the world, there are now about 8 million or 8 billion people. That means 1/4 of the people around all over the world don't get regular supply of potable water. Most of them, for sure, are in Africa or South America, but all over the world, there is the problem of 1/4 of the people that don't get this. Also, they wrote this year that about 800 million people all over the world have no approach to potable water. I say, what I said now, the change of the number is from this year. Before about 3 weeks, it was written in the New York Times what the United Nations declared this year. That means what is written here, 2020, it should be now 2021. Okay, next slide, please. Also, it's written in the New York Times that every 30 seconds, that means every half a minute, a child less than 5 years old dies from lack of water or polluted water. When you speak about one child, you say, but if you calculate it to a year, you get that in a year, it's around 1 million children are dying all over the world because lack of water or polluted water. Think about it. 1 million people, 1 million children under 5 years old die every year from this problem. By the United Nations, all over the world dies every year about 2.3 million children every year from a lot of things. For example, sickness, accidents, cancer, or whatever you think. But 1 million from them, that means about 45% of the children that dies every year are from the problem that is given in this slide. That means lack of water or polluted water. It's something that really, if you think about it, it's horrible. You say, oy vavoy, we say in Israel. The next slide, please. Also, they say in what they spoke about 3 weeks ago, that about 200 million hours every day, pay attention, every day, are spent by women to go and buy food, to take water from the water source and back to their home to bring water. These women can do another things instead of going to the water source and coming back to their home. And don't forget that when they take it, not all the water that they take in the water source are getting back home. A lot of it is put out on the way. And these women, in these 200 million hours every day, can do another things to help their families or to help their countries. Please, the next slide. You see here the women. It's nice, and you see here another women that go, and for sure, a lot of water that they take from the source is not, they will not get it home. It will be put outside on the way. The next slide, please. In Israel, the data that here in Israel are for the year 2020, that means the previous year. In Israel, we have about 9 million people. Don't laugh, that's all Israel. By the noise we make in the world, you think we are 1 billion, but we are only 9 million. The consumption of potable water in Israel is about 1.5 billion cubic meter a year. 60% of it goes to the citizen for drinking. 15% is export to Jordan and Palestine, and the rest to agriculture. Agriculture gets also water, treated water from what we make. Israel is the leading country by percentage of treating water, the sewage water. The NRW in Israel is about 9.5%. What I would like to say that Israel supplies a lot of water, you see, 15% to Jordan, because Jordan have a huge problem of lack of water. And Israel decided to help them and give them a lot of water, and also to the Palestinian Authority and Gaza district. Even we are in a big conflict with them, we give them, you see the amount of water that we give them every year, all the time, and I can tell you that not all the time they pay for it. But we consist and give them all the time the water they need, because without water, there is no life. Next slide, please. In Mumbai are data that I got from nice people in Mumbai. These are the data they sent me, that in Mumbai are about 14 million people. You see, it's nearly 50% more than Israel in Mumbai. The water supply in Mumbai is 1.5 billion cubic meter a year. It's the same like in Israel, but there is a lack of about 0.5 billion cubic meter. That means, 0.5 million liter a day. It is about 0.16 billion cubic meter a year. The target of Mumbai is to add water by 2 things. One thing is building new reservoirs, like for example in Garjai. I hope I spell it good, for example. And another thing is to start to use treated water, especially for gardening and cleaning. And by this, you can cover what you need. This the nearly 500,000 cubic, it's 0.16 billion cubic meter a year. Also, another thing is that in Mumbai, the NRW was the last year 38%, and the target, as Mr. ROMIEL said, is to decrease it to 25% by year 2030. You see a simple formula that 1.5 billion cubic meter a year, if you multiply it by 38%, you get to 0.57 billion cubic meter a year that are NRW in Mumbai. It's very high percent, and for sure you have to decrease it. Next slide, please. Here you see a man from Mumbai that is sitting near a reservoir and thinks to himself, a lot of water I see in the reservoir, but I don't get water at home. The supply is not good. You see, he is holding his head and says, how can I get the water home? Next slide, please. What is water loss? Now we'll see a formula. The water loss is the difference between the amount of water, please continue, entering the drinking water area system, and the amount of water that are used plus export plus change amount of water in reservoirs. Okay, please, the next one. How you can minimize the water loss? The next, please. One thing, the first thing is changing old pipes. If you have old pipes that are from time to time exploded, that from time to time are broken. So from this broken pipe, a lot of water are getting out and rising the NRW. The second is continuous surveillance along the pipes and related water supply infrastructure. That means you have to get people that should go every day along the pipes and see if there is a problem along the pipes. If these people see problem, you have to shorten the time required from identify the leakage or the burst of the pipe till the repair. That means you don't, if every hour that you wait, you lose a lot of water. So you need to see the problem and immediately to repair it. Please continue. You have to install proper water meter in the right place with correct installation. I would like to say that in Mumbai, there are nearly 500,000 water connections, but only 70% of them are metered. That means about 30% of the connections, of the water connections in Mumbai, it is no metering. That means water flow to customer and no one knows how much water they use. So it influences the NRW. Also in number 4, it's written, it's not only questions of putting or erecting the meters, it's also a question how you install it. You have to install it in correct position. What is correct position? It should be another lecture about water meters and what is the correct direction. After you put the meters, you have to be in the site to see that the meters are working. That means they are not damaged, they are not broken, they are not stolen. You have to continue to be there all the time on the site itself to see that the meters exist and that they are working. You don't put them in the site and you come after 2 years to see what happens. No, you have to be there in the site to see that they are working well. Next, please. Theft, possibility of theft. Theft of water is also a very big problem in Israel. In Israel, we get a lot of theft of water from pipes and accessories, especially air release valves, And we, in Israel, we spend a lot of effort to reduce this problem. For example, we erect a combination to close the accessories that it should be difficult to take from them water. Another thing, we erect monitors to send us alarm when you see that there is a theft. We are making a sighting along the pipes all the time. That means the problem of the theft of water in Israel is especially because the price of the water is very, very high. In Israel, the price of the water can come up till $5 American every cubic meter. I say it can come up till. It starts from low price, about $2, and it comes up till $5 for every cubic meter. For this, we get a lot of people that try to steal water and not to pay for it. And the last thing to lower the water loss is to lower the pressure of water that you supply. Next, please. We see here a lake with that is all the time from a small hole that is with the connection of the plastic pipe to the main pipe, that if you don't repair it immediately, you will get lack of water. You will get water loss. How much water loss? It's a combination of the pressure that influence this. Okay? Next, please. Here you see what happens when you have the small holes, and you see that when they get to the ground, you see the sign of the dollar. That means the drops of water comes at the end to money, and you have to take care of it. Next, please. Here you see very big amount of drops from old pipe that for sure the lack of water is very, very big here. Next, please. Here you see a slide that was shown before. It was water are in the pipe, but you see a lot of water are going out from the pipe. The women take water from here, maybe also from drinking, to drink it. And for sure, it can be a very big problem by the health of the people that drink this water, as the donkey that is in the water makes some things that are not good for potable water. Let's don't speak about it. Okay, then next, please. Here you see the NRW in about 2 years ago. I don't have data from the last year. That means from the year 2019. You see the NRW starts in Singapore 5%, and in Mexico, it's about 51%. Here in this diagram that I got from the data of United Nations, it's not written, not about Israel. As I told you, it's about 10%, and not about India. As far as I got only the data about Mumbai, that is 30-something%. Okay, now the time is, please, the next one. You see, the photos were taken, I wrote, and now for questions, I will try to answer the question, please.
Thank you, Levy. Frenkel, that was fantastic. We really got a few questions that have come up here, and I would like to sort of go through them with you. One of the important questions is NRW affected only by water leakage, or are there other factors that are also taken into NRW accounting?
Excellent question. NRW is not affected only from water loss. The most percent of the NRW is water loss. So for these, more than 50% of the slides were about water loss and the reasons and what to do. But NRW is also affected. For example, if the municipality, it costs to her to take from the well or from everywhere 100 rupees. And the law in India allows her to take from the customer only 80 rupees. That means that for every cubic meter, this municipality is in a lack of 20 rupees. That means also if there is no water loss, they will get NRW. It should be combination also of the, I don't know, in Israel, the government decided what should be the price for the customer. I don't know in India how it is, if it is so. So if the government decides that you have to pay some amount of money and it's not covering the price you have of energy, for example, that's NRW. Another thing that can affect the NRW is not efficient company that supplies the water. That means too much workers, that most of them are not working, only drinking coffee or tea all the day, too much secretaries, too much managers that take a lot of money to their home. That means also these affect the NRW. Let's say if the company is not efficient enough, so you get NRW very high. But as I said at the beginning, the most important thing is water loss. You have to fight against water loss, and then you get this NRW. In Mekorot, where I worked before till I retired, the water loss percent was about 3 till 3.5%. Okay? It's very fantastic, and Mekorot spent a lot of effort to reduce it to 3%. It's a lot of effort, and as I said before, it's another lecture to be done, how to fight against the water loss. Okay, another question if you have, please.
Yes, we have a few questions actually. The other one of the people have asked is, what is the influence of pressure on water loss?
Okay, there is a simple formula. There is a simple formula that I wanted to show you. If you remember, it was a slide of a black pipe that enters a main steel pipe, and there is a leak. And I prepared it at the beginning, a formula. I will show it to the audience now, a formula that shows the connection between pressure and the rate of flow that is because of the the pressure. For sure, the third thing of this formula is the area of the leak. I wrote it in a small. I hope you see it well. Do you see it well?
Yes, I think that's fine. I think we can see.
That's fine.
Yeah.
You see the formula, I wrote here the connection between pressure.
Yeah, we can't hear. Yeah, please. Yeah. Okay, now we can hear you better. Yeah. Okay.
Okay. Between pressure P and rate of flow Q, it's certain that Q is the area multiplied by the square root of 2G. G is the gravity, nearly 10 meters per second per second, multiplied by the pressure. I wrote here a small thing, a small two formula, one in black and one in blue, that is said, okay, we have a hole of diameter of 5 millimeter. What is 5 millimeter? It's something like this. This is 5 millimeter. You see, I hold my pencil. This is diameter of 5 millimeter. What happens when the leak is through this area? If the pressure is 5 atmosphere, then the leak is about 1.33 cubic meter per hour, and in the year you get to nearly to 10,000 cubic meter. But if you reduce the pressure to the minimum needed, you can't reduce it to 0 because you have to supply water. In Israel, the minimum pressure that you have to supply to customer is 1.5 atmosphere in Israel. It was before 2 atmosphere, but in order to reduce the water loss, the government said that the minimum should be 1.5. So if you reduce it to 2 atmosphere, then you see that you get in a year only 6,000 cubic meter a year. That means nearly half of what you lost when the pressure was 5 atmosphere. I don't know if you have in Mumbai or in India some data or some law that what is the minimum pressure you can supply to the customer. I don't know. Do you have any law? What is the minimum?
I'm not aware of it currently, or what is the law, but I know that they measure the pressures at several points, but not at the building level.
I see. I see. This is the minimum. This is the minimum. We can't give less than it. This is the minimum. For sure, if there are some buildings that you have to give also water with pressure against fire, so it's not 2, it should be minimum free atmosphere. But for regular customers in Israel now, the law says at least 1.5 atmosphere. So I put it a formula of what was the law before about half year of 2 atmosphere, and you see also 6,000 cubic meter a year, it's a lot of water. A lot. It's very, very big amount of water. Okay? I hope, are there another question, Romiel?
Yes, we have a couple of more questions, but unfortunately time seems to be a bit of a constraint. But I would like to ask you just a couple of questions. Now, for countries like cities like Mumbai, which have a piping system which is almost sometimes 200 years old, because it was laid by the British, the main pipelines were laid by the British. Is it possible to reduce our NRW from figures of 38%, even to a reasonable 10% or 15%, with under the circumstances that we have such old piping? In fact, lots of our piping is sealed with lead because of the old British systems. Is it possible to do that in a 10-year timeline?
It is possible, but it's not a question you can make it from today till Sunday, the coming Sunday.
Sure.
It's a very big effort to do this. You have to split Mumbai to areas. Every area you have to start putting meters. You have to start to put pressure meters. And you have to, as I said, you can do it, no problem. I work now with one municipality in Israel, I work now, that after 3 years, I succeeded to reduce the NRW of this municipality from 22 to nearly 14. As I told you, not 3 years, 2 years, sorry, 2 years. In 2 years, it's not a thing, a miracle that you can do it in 1 day.
Sure.
You understand? It took about 2 years to reduce it from 22 to 14. 1/3, and it's a lot of effort done by this municipality, and they are not saying, okay, we got to nirvana, we will do nothing. Our target is in a year to lower it to 10% or less. We are not staying at home and say it's enough. No. This is a thing that you have to fight all the time, but you can do it. No problem.
Excellent. So that is basically what you're saying, is that this is an ongoing effort. It never stops. You can't say, I am done with it. It has to be a continuous strategy and continuous effort on behalf of the municipality or the authorities to build this NRW and create it, and constantly keep changing pipes and attending to leakages and metering. And so this has to be a long-term effort.
Excellent. Yes. I don't know how to say it in English, but I hope that Niv is with us. Niv, are you with us? In Hebrew, we say, Lanuach al zerea dafna. Dafna, I don't know. You know, the Greek, they made for the winners in the Olympic Games,
right,
from, you know,
olive branch.
Yes. You can't rest and put the olive in your head.
On your head.
Yes, no. You have, that is a war that is not finished.
Excellent. On those happy words, we will thank you so much for your time. It was really interesting. And of course, we will be in touch. And thank you so much for this insight.
Thank you. And Mr. Romiel, if there are more questions, please send me by mail or by WhatsApp, and I promise you that tomorrow I will answer them.
We'll do that. Thank you so much, Levy.
Thank you, so everyone, and I hope that my English is understandable. I hope.
Yes, otherwise we would have all switched off by now.
Thank you. Thank you.
Thank you,
So,
Levy.
as I told you before, I have to leave you. I have something. Thank you, everyone. Thank you, and we'll keep in touch later.
Of course. Thank you so much, Levy. Bye-bye.
Bye.
After that wonderful talk by Levy, we now are going on to an extremely important topic, which is agricultural water. As we all know, agricultural water in India consumes 80% plus of the water consumption. And to address this issue in its totality, I could not think of a better person than our friend of us, Dr. Suresh Kulkarni, who just retired as the Secretary of Maharashtra Water Resources Regulatory Authority. Dr. Kulkarni, it's over to you.
Yeah, thank you so much. You want to say something? Please go ahead.
No, please. It's for you to start, sir.
Yeah, this is just a brief introduction about myself. I'm an agriculture engineer and spent about more than 35 years in the water sector. I served in Maharashtra and Valmi. Then I also worked at the international organization called the International Commission on Irrigation Drainage at New Delhi. And later on, the government of Maharashtra's Maharashtra Water Resources Regulatory Authority. which is the only functioning authority in our country. It's my great pleasure. First of all, I would like to thank you, Mr. ROMIEL, Samuel, for really inviting me and sharing some of my whatever I learned during my last 35 years or 40 years career. I think that's enough, and let's start. The first I will share from my side this one. Yes, sorry. Yes. So this is. Can everybody is able to see full screen?
Yes, sir. We are able to.
Yes. Okay. Very good. Very good.
Right.
Thank you. Thank you. Great. Great. So coming to this, I will just quickly go through the global. Of course, water is always a local subject, but just to get an overview, what is happening at global level, what our thinkers are trying to, sort out the water issue. So the OECD, they have been doing a lot of work in the water sector, and they say that because today's topic is about agriculture, so I will be talking more about agriculture, not about everything about the other sectors. So particularly agriculture, if you can see, in 1900 something 525 billion cubic meter of water was used for agriculture, and in 1950 it became doubled almost. And then you can see the figures available from 2000 onwards and right up to 2020 today. And they have projected what will be the requirement of agriculture, domestic, electricity, and manufacturing. It is global. So if you can see the water, demand or water supply to agriculture will go on reducing. It is not going to increase because there is a great demand from other sectors like domestic, electricity, manufacturing. And this is especially in the Europe and US and other developed countries. But in India, it is the different story. Now, population has a direct impact on the water demand. This is just in 1950, the population was just 2.5 billion, and now it is almost 7 billion population is there in the world, and it is projected that 9 billion plus. Somebody says that 10 billion population will be there by 2050. There are different estimates by the experts. But what it says that as compared to 2010, in 2050, the food requirement for the population is 56% more food. But if you see, it is not exactly the more food, it is the kilocalories. That means it will require higher kilocalories because these changing diets, the population, urban population all over the world has a very rich diet now consisting of dairy products and meat all over the world. That is the reason that kilocalories will increase, and that in order to satisfy the kilocalorie requirement, higher kilocalorie requirement, we need to produce more food because food is converted to meat first in many countries, and then that meat is eaten. So that requires a lot of food. So to produce more food, we require a lot of water, and it is projected that there will be 15% increase in water demand. So this is huge. And if you see globally, the water requirement for different regions is different. For example, in Europe, it is not just 20%. But you will be surprised to know that even if you say Europe, for Germany, it is just 1%. 1% of water is required for agriculture, and rest they use for the industry purpose, even for environmental purposes in many other European countries. So Asia in general consumes more than almost 80%. But if you see the South Asia, that is a large part of the India and Pakistan. So it is exceeding 90%. So the water requirement, the water withdrawals for agriculture are very huge in South Asia. It is a hotspot of agriculture. Within the South Asia, if you see for different countries, it will be different. So again, that we'll see shortly. So coming to India, a lot of studies are available by different organizations all over the world, and there is a Water Research Institute which has prepared such a map. This which shows the water stress, particularly surface water stress, which is worked out by total water withdrawals. It's at the 210 base, that's the base level, and divided by mean available blue water. Blue water means water which is there in the rivers, groundwater, etc. That is called as blue water. So this is average of 1950 to 2008. So they have shown this map for the entire country, more or less. So it covers, you can see the boundaries of the state. So this is worrisome that in most of the states, there is a stress of medium to high and high, like states like, Rajasthan, part of Gujarat, and entire Haryana and Punjab, most of the Punjab, almost. There is a high water, extremely high water stress. That is more than 40% of water is withdrawn, which is available. And literature shows, if you read the word literature, you can see that once you cross this 40% level, then it will affect the environment. So that is the reason that environment flow, our rivers are dry because there is no water. Most of the water is used for our agriculture and other uses. So the threshold which has been proposed by the expert, that we should not exceed the 40% limit. That is the maximum limit the water should draw. That's what. And now talking to the data, there is a lot of water related data is available in different Central Water Commission, Ministry of Water Resources. There are various reports, the Niti Aayog recently. So if you can see that they always the demand, I don't find the use. These 2010, 2020, 2050. There was a commission, National Commission on Integrated Water Resource Demand in 1999. I was there at that time in Delhi, and I also contributed this particular report. So you can see the varying figures for irrigation, 557, 611 for 2025, and 2050, 807 billion cubic meter of water has been shown. But on the other hand, if you show the Niti Aayog shows different figures. So there is a lot of this. So data is a very important factor that I will be talking later about this, that although a lot of figures are available, but there is no unanimity among the figures. How much water is really being used for different purposes in India? Now, very briefly, that agriculture development in India. India is a very strong country. It's a leader. So China, of course, you can see the number one as per the value of the agriculture product it concerned. Then second comes India, then USA, Indonesia, Nigeria, etc. These are the countries. Now, if you see this agricultural water withdrawal in India, as per the figures available, I'm trying to compare with China, because always we compare with China, not with Israel, because from my point of view, Israel is a very small country for us, and having a different political system. Of course, China also a political system, but we are talking about agriculture, and even the irrigated area is almost same in China and India. But if you see the consumption of water, China just almost 50% of water it is withdrawn for irrigation purposes. And even the total water withdrawal in China is 554, is much less than India. So this is the major concern for us, that how to really reduce our water demand. So particularly, we are talking about agriculture now. So there is a huge, people say there is a huge scope for reducing water demand. And if you see the this employment opportunities here in India, this agriculture still, of course, is declining, but service sector is rising, and industry is almost flattened. If you see in China, agriculture sector, the employment in agriculture is drastically reducing. Less and less people are engaged in agriculture, and more in service sector, and also in industry sector. So this is also a matter of concern for us, how to really shift the agriculture employment to other sectors. Then coming to our proper subject today, agriculture water management. We need to understand what is agriculture water management. It is not just irrigation. It is a big spectrum. It's a large spectrum, starting from purely rain-fed to fully irrigated. Under purely rain-fed, there are many areas worldwide where agriculture is only mostly rain-fed. In humid countries like in Malaysia and Canada, etc., it is mostly rain-fed. And within the rain-fed, there is water conservation measures are taken. Then supplementary irrigation also. That means it is not a full irrigation, but supplementary irrigation. Then we go for water harvesting. This is also a part of agriculture water management. Then real blue, that is the full irrigation, is groundwater irrigation, and then surface water irrigation. So these are the two irrigated, real irrigated, and then there is the rain-fed area where there is a mix of supplemental irrigation as well as rain-fed. And then comes also the drainage, which is really a neglected part, particularly in India. So drainage is an important factor, important aspect of agricultural water management that we should not forget. So all this together, comprehensively integrated way, we should call it as agricultural water management. It includes both rain-fed and irrigation. Now, very quickly, if you see the irrigated area, I'm really talking more since I worked more in irrigation. I'll be talking about the irrigation in the today's same webinar. In 1961, the area was only 139 million hectares. And then it rose quickly. The rate is, you can see, 2.3%. The yearly rate of increase of irrigated area was 2.3%. And then it has slowed down slowly, efficiently 1.3%, 1%, and now it's 0.6%. Why it has happened? Because there was a lot of activity between 1970s and 80s. There was huge boom of dam construction all over the world. You know, the dams are a very important source of irrigation. And as per the ICOD, this International Committee for Large Dams, there are more than 52,000 large dams in the world globally, out of which more than 5,200 dams, large dams are there in India itself. So India is also one of the major country having the large dams. And we constructed many, many dams. And of course, China is also a big country where the dams are being constructed still. But we are in India. But in most of the Western countries, Europe and US, etc., the dam construction activity is already finished. There are no more construction dam. On the other hand, they are really decommissioning the dams many places because of the environmental pressure. So if you see here, by 2030, now presently something like 300 million hectares are irrigated, area equipped for irrigation, and there is not much change in future. But 2050, maximum 380 as per the FAO. It says that there will be a slight increase in the irrigated area. There is no more scope for increasing the irrigated area in future because less water will be available for agriculture. But it doesn't mean that you are reducing the food production, but you are increasing the water productivity. This is what, and major contributor is India. India, there is if you see that present irrigated area is, we say that only 96, and there is a possibility of going up to 140. That we have huge plans for increasing the irrigated area in India. But where from you bring the water? That is the question. Now, if you see the irrigated area, total in summary, we have a cultivable area of 82 million hectares, and there is a gross irrigated area about 96 million hectares. Net irrigated area is 68 million hectares. That is a net irrigated area, which is 37% of the cultivable area. And the purpose of showing this graph is very different. That you can see from 1950 onwards, what is happening. The very alarming situation, particularly in India, which is not there any country all over the world. Groundwater is increasing and canal irrigation is shrinking. If you can see here, this continuously canal irrigation is shrinking. And now if you see the canal irrigation is only 24%, while groundwater irrigation is for 63%, and it may increase in future. So this is a matter of worry for all of us. That how to really reduce the groundwater withdrawal for irrigation and then increase the share of canal irrigation or surface irrigation like this. And today we are talking about the various technologies. Sprinkler irrigation, we have 6 million hectares. Micro irrigation, that is 5 million hectares. And China is equally, I think we are the same level of using the sprinkler micro irrigation in the world. China and India is similar. Now, if you don't reduce the water requirement, so it is going to impact the GDP. So this is a matter of concern. So we have to be very, very, very serious about the use of water for irrigation. Now, groundwater, already we have listened to experts like Mr. Jain, who told about the water, and also from the aqua dam, the lady. that the most important crisis in India, everybody, whole world is talking about the groundwater, because 90% of the groundwater is for irrigation and 10% for domestic and industrial uses. So now we need to really, we know that India is the largest groundwater withdrawal in the country. It has been really, I feel very ashamed in many international fora when people say like this, but we have to do something, definitely. So the one small effort I could notice in Punjab, because Punjab has been always criticized for using the huge amount of groundwater, so they are doing some experiment with the scheme called like Pani Bachao Paise Kamao. That means whatever the water you are using, that they say that it is your entitlement. And if you can reduce your entitlement, they'll be paid. Farmers will be compensated for that. That means at least we are reducing the water, because it is a huge crisis, groundwater crisis in Punjab. So that is important. And our neighboring country and in China, there are a lot of efforts are going on to reduce the groundwater by using technology. So they are using the smart card. That is, prepaid smart cards are being very popularly used in Bangladesh. Even you can see this lady is using this. And there are more than 1 lakh users in Bangladesh who are using the prepaid, where water is measured and water is priced. So I think this is a very serious matter, and we need to think in this way. Then about the irrigation, you can see the Punjab and Haryana, highest irrigated area. Almost you can see here the irrigated area is almost 95%, 100%, Haryana, Uttar Pradesh, etc. And cropping, this shows the cropping intensity. And the blue shows the irrigated area. So cropping intensity is very high in many places. These places, Punjab, Haryana, Uttar Pradesh, Bihar, northern India, the Ganges Basin, where a lot of course, water is there and a lot of irrigation is taking place. So this is the, just to show that how irrigated, you can see those are the areas, southern areas, including Maharashtra, the irrigation is less than 20%. But again, the figures, data is not correct. So we need to talk, I will talk about that later. So this is the situation of irrigated area and cropping pattern in the country. Now, a very interesting thing which you like to present, the paradox of irrigation efficiency. We talked a lot about the irrigation, improving irrigation efficiency when I was in Delhi. And since 2005, there is a national water mission. Everybody says, politicians and their bureaucracy says that we need to increase the irrigation efficiency by 20%. But we need to understand what is irrigation efficiency and does it is going to help us in improving the water withdrawal. So there are basically from the reservoir to field. I'm talking about the canal irrigation here because we always criticize that there is huge losses and only 30% water reaches to field. So we need to distinguish that. First is water is being conveyed from dam to field. That we call as conveyance efficiency. And we have long, very big dams as well as huge network of canals and distribution network. And the leakages, the losses are there. We heard about by the previous speaker about the NRW. Similarly, there are such a lot of NRW also in irrigation sector. But the real losses we can see the seepage, leakages, spills, unauthorized use. This is the NRW. Evaporation. This is the real loss. Evaporation from the shrubs and weeds which are growing in the canals. This is the evaporation loss. So there are. Then we come to the field. When we come to the field, when water is applied to the field, what happens? There are losses of deportation. When we apply more water than the requirement of the crop, the water seeps down below the root zone. That is deportation. And runoff. Sometimes water goes beyond your field, and that is not available to your crops. Then we also call generally as so-called losses. And evaporation. Evaporation from the surface. The water surface as well as the field surface. That is evaporation. It is a real loss. Now, I would like to just bring, there are two types of losses, the consumptive use, beneficial consumptive use and non-beneficial consumptive use. Because short of time, I will not be able to tell, but all the losses are not real losses. For example, water lost through seepages, leakages, and depercolation meets to the groundwater, and that is reused again. Of course, it doesn't mean that we should allow that, but it is not a real loss. Real loss is because of evaporation, which is once water is evaporated from the water surface or from the field surface, it is not available for the It goes to the hydrological cycle, of course, but is not available for the further use. Now, another problem in India is not only of reaching water to the field, but how much water, that is, we are not doing really scientific irrigation. We need to apply why our productivity is less. One of the reasons, besides many other, is we are not able to apply the growth stages, water when the water is needed. Sorry. Then, because there are critical growth stages of the crop, then depth required. If the crop requires 50 millimeter, we usually apply 100 millimeter. This is the great problem. And non-uniform water application, we are applying uneven water. There are many factors which really affecting our water productivity. Then we need to modernize. We will not spend much time. So what is really needed? We require a lot of investment that all other countries are doing, like canal lining by different geotextile material. Then pipe distribution system is posed in many states like Maharashtra, in Madhya Pradesh, they have started now the pipe distribution system. Then the canal networks, modernization of canal control systems. So such type of systems are there, for example, in Australia, which regulates the water flow and also measures the water flow. And then these are the SCADA system which are used. And agriculture extension, there are mobile irrigation laboratories. We have to reach to the farmer to solve their problems. So these are all the part of modernization. So this is very important, which really needs irrigation efficiency. Then coming to the various technology and measures in saving water. This is one of the very useful technology being practiced in northern India, Punjab, Haryana, and some of this, I heard that in Maharashtra also it has started. That is laser land grading technology for water saving. That means by using the laser, I will not explain here because of short of time, that this is the laser transmitter, and then you can see the laser beam, and there is a tractor driven leveler which adjusts automatically the level of the land. So you get a very precise irrigation, even up to 0.2% or 0.3% slope. If you want to give, you can achieve that with this type of technology. Then we heard from our previous speaker and earlier speakers, measurement of water, very important. We are not measuring even our drinking water supplies. What to talk about the agriculture water supplies? We have in Maharashtra, for example, the government has been trying to install this cutthroat film for at the minor head, but there is no measurement at the field level. So farmer don't know how much water he is applying to his field. And really, I feel very sorry that even the agriculture university has never tried to provide any sort of help to the farmers for measurement of water. Even this type of small siphon tubes, which are very extensively used in many European countries and USA, that will help us farmers to measuring how much water is being applied to the crops. So this is a gated pipe. I think this is a simple techniques, but this is unfortunately it is not used in India. We need to use this. So we know how much water is being applied for this, and where we are using the lift irrigation schemes. Where when I was in MWRRA, we tried to make it mandatory to use ultrasonic meters to all lift irrigation schemes. But unfortunately, it's not being practiced. There is a lot of opposition from the lift irrigation organizations, which is not really good. So you can see in Bangladesh, which I already shown, prepaid cards are used and water is measured there. So measuring of water, because we don't know how much water is being used for agriculture. Sorry. Yeah. Then coming to the, Then there are various techniques. I will not again devote much time because it's a well-known technique. Sprinkler irrigation system, and all over the world, something like 40 million hectares are under sprinkler irrigation all over the world, especially in US and Europe. So with this, there are a lot of innovations are there in sprinkler irrigation. You can see this is called a LEPA system. This is a low energy pressure application system is there. That means you can adjust the drop tubes depending upon the crop height. So this will reduce the crop evaporation and wind drift losses. So these are a lot of innovations are there, and we need to adopt this type of technology in India. Unfortunately, we are still stuck up with the very rudimentary type of sprinkler system in India. We need to go ahead with this type of system so that we can reduce the per hectare cost of water application. And the most talked system in all over the world and in India is micro irrigation, which we say that not only saves water, it saves fertilizer, it saves energy, and also labor. So this technology is available in India now. We are equally competent, in technology, and fortunately there are more than 100 companies in India who are really manufacturing this, and there are world-class, renowned companies are there in India, particularly in Maharashtra. So definitely it has revolutionized the way water is applied to the crops, but there are many issues because one is very expensive system and its maintenance, etc. is very, very complicated. So we need to teach the farmers. So for example, this lady, this is a picture from Nasik from, thanks to the NetAfim, they have provided the picture, and it's possible. The women farmer, again, we have to involve the women actually in irrigation. They do the irrigation job much meticulously. So these systems are available in India. So we need to apply this use system to many appropriate crops. Many people say that you should use all system to all the crops. It is not possible because it is expensive. Also, from the practical point of view, it is not feasible. Just this slide, I would like to show the rainwater, because as an agriculture water management system, we also need to bother about the rain-fed, because rain-fed system, almost 60% of area in India is rain-fed, and in Maharashtra it's much more. So these are a lot of experience in our agriculture universities. We can see this MWRRA Prashid, they have tried to develop such technology for the small farmers, how to really conserve water. These are the contour furrows, where we can save, you'll be able to facilitate saving of more, conjuring of more rainwater, like these bunds. If you have the contour bunds like this, then also there's a trenches along the contours, which will conserve a lot of water. Then they gap in small bunds, and then the farm ponds. So you can see using the farm pond, the small farmers is able to, use this sprinkler irrigation. So Maharashtra has done a lot of work in this water conservation, but unfortunately the maintenance part, further maintenance part is missing, and that is very important part. And I just want to show this. This is a small pump, which is a solar pump, which has been developed by some organization, and this is called a future pump. This is a very interesting pump. This weight is only 19 kilogram, and you can lift water to the total height of 15 meter. Total height. So it is portable, and you can lift water from a small stream or from pond. Such this type of pumps needs to be popularized because it operates 100% on the solar. And I heard that, I came to know that the cost is about 50,000 rupees for this pump, but with subsidy, I think it's possible for the small farmers. Then coming to wastewater, I will not spend, because we have heard a lot about the wastewater. But only thing that there is of course, all this previous speaker has already mentioned about the great scope for using, the wastewater in agriculture in India, and all the figures, statistics are available for everybody. And you can see that we use a lot of raw wastewater for irrigation, and there are a lot of stories from the media, etc. And that is creating a big health hazard. Most of the vegetables, in the peri-urban area, which you use around Mumbai, Thane, Pune, we don't know exactly whether they have been irrigated by wastewater or by treated wastewater. So this is major concern. This is one of the reasons that we need to really treat water. And our colleague, on Tuesday also, our colleague has said about the wastewater. So during one of my visit to Israel, I could see how they are using this really treated waste. We talked about a lot about using wastewater for agriculture, but a lot of thought, a lot of investment goes behind it. That means how to really bring treated wastewater to the field. So this is the very elaborate mechanism. They have developed this all over the country. They have a separate grid pipe distribution system to bring secondary treated water to the field, and they have colored as a purple color pipe, which means that if you see the purple color water pipe in the Israel, that means it is carrying the treated wastewater. You are not supposed to drink it. Of course, nobody drink there, but there is a caution. And these days, this water is used by either drip system or sprinkler system. They are, of course, they have to use it. Otherwise, there is no way that they can use fresh water there. So I think in India also, the very important factor is that one thing is treating wastewater. That is one. But I also learned that there are no takers. Even if you treat the water, but excepting some thermal power plants, how to carry the treated wastewater to the field. That is again a big challenge. We need a lot of investment, lot of policy making in bringing treated wastewater to agriculture. Then we are talking about the productivity. I think this is a famous diagram everybody must do. This is by a NABARD study, we sponsored study, and it is just a recent study. And if you see the paradox again here, but sugarcane and rice, these are the two crops which are really, consuming a lot of, these are water guzzling crops. What is happening? Just a comparison, Bihar, Uttar Pradesh, these are the states where sugarcane is grown on a large scale. And it shows, try to show both water consumption per kilogram and what is the land yield of the crop. If you see the Bihar, in Bihar, it produces about 1 cubic meter of water produces 12 kilogram of sugarcane. But if you see the Maharashtra, it produces only 4.5 kilogram of sugarcane with 1 cubic meter of water. But this you can see the graph, the water productivity, from the land productivity point of view, Bihar has the lowest yield, but the water productivity is highest. And Maharashtra, you can see this, Tamil Nadu has the lowest water productivity, but lowest water productivity, but the yields are very high. So this is a very interesting study. What does it mean? Similarly, in case of rice also, it is the different story. In Jharkhand, the water productivity is very high, but yields are relatively higher, of course. But there are many states where, for example, let us take Punjab and Haryana, where the yields per hectare of crops are very high, but water productivity is very, very low. That means they are applying too much of water to the crops. That is the reason that there is great crisis in Haryana and Punjab, groundwater crisis are there. So what is really important from these graphs to learn that you should, now there should be sort of a regulation that where the crop productivity is the high, there only the government should encourage that type of crop. That means these states like Maharashtra and Gujarat should think for crop diversification. Otherwise, there will be a big crisis of water in our states. I'm taking example because Maharashtra sugarcane is always a matter of discussion, not only at national level, but at even international level, people side. And Maharashtra, of course, we can spend 1 or 2 webinars on this. But what I want to show to this is that share of sugarcane area in Maharashtra is 15% of the total irrigated area, surface water and groundwater. But how much water it is consuming? It's consuming almost 50% of water. That is about 22 billion cubic meter of water is being used by the simple sugarcane area. Although we are talking of converting of drip irrigation for the sugarcane, there is only 2.5 lakh hectares are under drip irrigated area in Maharashtra, and rest 7.0 lakh hectares are still surface irrigated area. So this is the state of affairs. So even if my calculation, even if you convert all 100% area by drip irrigation, the water crisis will not be solved. Only less water, more area will be irrigated. So what is happening? Other crops that use water resources more efficiently cannot compete economically and politically with the sugarcane. Because in Maharashtra, there's a big discussion how to reduce the area, or how to make diversification. But this sugarcane crop is very politically strong. And there is no FRP also for other crops. So these are the reasons why this sugarcane is really popular in Maharashtra. We cannot blame to the farmers, but the policy is very important. Again, in case of the rice also, a lot of flood irrigation is there. You can see the puddling. It's just near to my residence. I took the picture. Now there are a lot of experiments are going on, like furrow irrigation, sprinkler irrigation, drip irrigation. Even drip irrigation is being tried for a lot of successful experiments are there for drip irrigation in many research data, but not on farmers' field. But sprinkler irrigation is used. But this is a picture from Brazil. They have used sprinkler irrigation on very large scale successfully. And this is a system of rice intensification. It's very popular and being used in India quite significantly, and many other African countries. This SRI system is used. And one of the system which has been developed at Philippines, IRI, is alternate wetting and drying, which is used by extensively in China. that instead of applying water continuously, that flooding fields, because this is what we have been doing, flooding fields for rice. It is not necessary. In that case, it is alternate wetting and drying. Let the water dry. That means they have developed a simple tool to be used by the farmers. This is a perforated cylinder. You just establish this cylinder in this field, and once the water level goes below 7.5 centimeter, below this, then irrigate. So this is this technology, like farmer-friendly technology tools, need to be introduced to the farmers, so that they will believe, and we have to demonstrate that this will not only help in reducing the water, but it will also increase the crop productivity and increase the fertility of the the land. So these are the things we need to do in the field. And one of the component of this agriculture water drainage is subsurface drainage technology. Drainage is a very important component, which we are really neglected at all, totally. And many areas, especially I'm talking about the Maharashtra and western part where sugarcane is taken year after year, lots of thousands and thousands of hectares are, are because of continuous cropping by sugarcane, and sugarcane, it has gone out of cultivation because of excess water application. It is one thing by irrigation, also by the, rains. Sometimes because of heavy rains, your crop remains inundated for a long time. So the crop, the damage is there. We need to really go for this type of technology, which is called as subsurface drainage. It is the perforated pipes we are placed so that we can reduce. These are the machines. This is the experiment in Sangli district, where a entrepreneur, a private person, has introduced this machine, and farmers can do it. And now government of Maharashtra is also helping now to lay the subsurface drainage system. This was done in Rajasthan. It was a big project in Rajasthan, and they did it, I think, on some 15,000 hectares. Now, again, the Internet of Things is really need to be introduced. We have to go keep pace with the technology which is being applied and tried by other countries across the world. Internet of Things, water data and forecast, machine learning. These are the things I will not spend much time, but this technology is there. We have to go ahead with this. Now, this type of technology is being used. These are the pictures from the Nasik farmer. He's using this latest technology of sensors. These are the sensors he has put in the grape area, because grape is a very important crop in Maharashtra. So they can invest. So one of the farmer, he has sent me pictures. So he's using this sensor, and this is total system of weather station, where all the data about the moisture status in these crops, root zone, the climatic factors, temperature, humidity, all the factors are really integrated. And then there is a weather app. This company which provides the services, there is an app from which the farmer can really get the messages when to irrigate and how much to irrigate. These are the two crucial questions asked by latest technology. And fortunately, we can see even the Mahatma Phule Krishi Vidyapith Rahuri, the team there has developed a very interesting irrigation schedule. It is an app they have developed, and it is available for all those farmers in Maharashtra who can really want to use. And they are also providing services free for when to irrigate and how much to irrigate. So this technology is available. We need extension. And this is a latest technology, and everybody is in the Western world, everybody is talking about this, that by remote sensing, there are a lot of now satellites are available. And by remote sensing, it is possible to decide when and how much water to apply for the crops. And there are already a lot of consulting services are also available. They charge to the farmers on per hectare basis. So these satellites measures the crop leaf temperature, solar radiation, leaf size and photosynthesis. And really the temperature, just like human body temperature, doctor sees that then they are able to diagnose proper. So by reading the leaf temperature from the sky, you can really know what is the water requirement of that crop. So these services are already available, and this is the picture I have gotten from EasyWatch. They are supplying this, And lastly, you can see this data. I think this is very important. I think that there is a lot of confusion. Even as I said, nobody knows exactly how much water we are using. We are all the guesswork, and different figures are available. And this institute like MWRRA, we are struggling really to get the data which is reliable and trustworthy. Unfortunately, the data is not available. And This is, I think, the biggest lacuna, one of the biggest lacuna in our country, that we are not keeping any reliable data. There is no proper water accounting and water auditing. Although we are doing it, but it is just a paperwork. And we are not able to do anything out of this. So this is just symbolic, showing that this is a big Airbus carrying 800 passengers. This is a very sophisticated machine, and there are a lot of in cockpit. You can see the very, very sophisticated instrument there. And imagine if the cockpit is totally blank, nothing. The pilot could not see anything. What will happen to this? You know, the Airbus. It may go anywhere. It may crash. It may land anywhere. I mean, this is the same thing happening because we don't have exact data. That's why we are not able to plan properly. And then finally, I think this is the conclusions of the way forward. I see that as long as water is free, almost free, because our friend from Israel has just said that the cost of water is ranging from $2 to $5 per cubic meter. And if you see it all over the world, the cost of water is there and people are paying it. We don't know. I always ask the question for the audience when I have the opportunity. Do you know what is the bill you are getting for how much you are paying for your water, even domestic water? 99% people are not able to say how much you are paying for the water and how much water you are using in your home. We are not able to tell. This is the tragedy. So because it is free and almost free electricity, we are being hitting the media that something like 40,000 crores of for the agriculture pump sets. There is a recovery with the farmers. I'm not saying that, but farmers want very good service also. Farmers are not encouraged to conserve water, therefore, because not only farmers, all population, unless and until we have a very strict system of water pricing. Therefore, water and electricity need to be measured. It should be measured, and price should be measured. That's first important. Pricing has to be decided. How pricing has to be decided, there are different ways, because there is a big debate on pricing. It should be sustainable pricing. What does it mean by sustainable? That your services should not collapse. That much recovery should be there. You should be able to recover the operation and maintenance cost, your establishment cost. You should be able to recover. Then only you will be able to provide the quality services. Because otherwise, your services will collapse, which has happened in the case of electricity supply in Maharashtra in case of agriculture. Then water saving potential of the sprinkler and microirrigation technology has been proven to be at the field level. There are a lot of experiments. All universities are doing how much water can be saved in all type of crops, but there is no study to confirm that how much is there any real water saving at the irrigation scheme level or at the basin level. Because basin is the unit, sub-basin or basin is the unit, it is a hydrologic unit, and we should be able to say, find out whether using this technology, are we saving water? There are a lot of studies have been done by FAO and many other international organizations. They said that it is a zero-sum game. If you save the water somewhere, that means if you are using the micro irrigation or sprinkler irrigation, whatever the water you are using, earlier water you are as a form of loss, that water was being used somewhere in the basin. That means the water is not a real loss. Real loss is that evaporation is a real loss. But if you see in the drip irrigation technology, there is more of evapotranspiration, and you are reducing other losses. So that evapotranspiration, you are increasing with that using micro irrigation, and which is not available. So that is we should not blindly do only micro irrigation, only sprinkler irrigation. We should also see that other, technological, strategical, and policy measures which will really reduce the problem of water shortage and water crisis. So we should not be just blindly do such things. I'm not just saying that these systems are not good. They are very good for that field level, but at the basin level, we have to see what policy measures we have to do. Then everybody talks, as I said, that improving irrigation efficiency. I have been hearing this improving 20% irrigation efficiency since 2005. Unfortunately, nothing is happening because we don't understand the meaning of irrigation efficiency itself. So this needs to be really on a real-term basis. We have to think what really irrigation efficiency means. Then encourage public and private partnership, because governments are constrained with the funds. And take any example of Maharashtra, they are more, completing all investment funds are being diverted for construction of dams, and the dams are again to be repaired. This is the thing, and less money is available for actual irrigation purposes. So all over the world, people are using the public, companies, how to involve them in irrigation operation and management system. So this should not be any taboo or stigma about involving private sector. We need to involve them. How to involve them? Definitely, we can discuss on that. Then groundwater is the biggest problem, which is under criticism all over the world. How to control this? Although there is a law where I was working in MWRRA, we had in 2009 itself, the Groundwater Act was passed, but very, very, I think, shameful, I can say this word, very sorry for that. But after even 11 years, nothing is happening in the field. And groundwater, there is a lot of problems and tankers, everything is there. And we really seriously should take this issue with the policymakers, why we are not really implementing this. And as I said, water data scarcity. What is happening because of scarcity and inaccuracy? There is no decision making proper. And we should be able to, with proper data, we should be able to, because whatever the water policy, we have a lot of national water policy, state water policy, everything is there. But these are the really feel-good, documents. All over people's experts from the outside say that these documents are only feel-good documents. There is nothing between practical and these are the only theory. So we have to really put up the actual facts, real facts. The facts are real, of course. So relevant data on water resources and policy must be reliably collected, trustworthy managed, and comprehensively presented to decision makers. Then only then only you should be able to take a good decision. Because we have, for example, integrated state water plan in Maharashtra, but people doubt about the data about it, very old data, and is it really of any of practical use? So such things are there. And finally, the agriculture extensions. We are talking about agriculture watermen. Whatever technology there, drainage technology, sprinkler technology, drip technology, alternate wetting drying technology, or this system of rice intensification. A lot of technologies are available even in India. So that need to be reached to the farmers. That is what is really agriculture extension is very poor, unfortunately. That's the reason what the agriculture productivity is very, very low. So ultimately, we should use less water, increase the production. And we should see that how to really limit the use of water for agriculture, but at the same time, increasing the water productivity. That should be our target and aim. I think finally, I would like to just say thank you for this. And just this is a QR code. Those who are interested, they can see that Telangana is doing a lot of very interesting experiment. That is regulated crop cultivation practices. That Telangana government has said that they will dictate which crops to be taken at which area as per the agroclimatic zone. And they will be paying to the farmers based upon their income. So that will really encourage farmers to take low water requiring crops. So you can read this article, which is written by one of my friends. You can go with the QR code, and this type of experiment need to be done. I think this is what I want to say with the given time. Thank you very much for giving this opportunity. Thank you.
Thank you, Dr. Kulkarni. That was, as expected, very engaging and intense 45 minutes of talking. We have lots of questions, unfortunately. But we will have, because of scarcity of time, we've decided that we will email them to you, and then we will respond to people. Right. But you have actually covered a huge area, which is 80% of the water consumption of the country. So to give you 45 minutes to do that was a great injustice, but I think you have done an excellent job.
Sorry for crossing the time limit. Sorry for that.
No, I apologize for only giving you 45 minutes to cover 80% of India's water. I think the apology is due from our side. But thank you so much. That was really intense. We've got lots of questions, but we will of course share with you. I thank all the participants for being here today. It was a wonderful and intensive session. And next week is our concluding week on Tuesday and Thursday, where we have the professor from Technion, we have a water expert from Bangalore, Vishwanath, we have Dr. Ghosh from Calcutta, from Observer Research Foundation, and we have our own Dr. Pushkar from the Mumbai University, who will be giving us talks on the the final aspects of the water, and finally water policy. So thank you everyone for joining us. We look forward to seeing you on next Tuesday. Thank you so much.